We're going to do a little temperature stability test on the Zener diode. I have about an 8-volt Zener diode hooked up, and first we'll apply just a little bit of heat to it. Now this is a little more heat than what you'd normally use. I'm using a heat gun, but I'm only going to put it on it for maybe a second or so. And you see it took off in the positive direction. It went over 20 millivolts positive. I'll take and cool it back down using just a little canned air. And we'll heat it up one more time. And cool it back down. So that's kind of a fairly drastic shift around. So let's take a look and see what a 3-terminal voltage regulator would do in the same circumstance. Notice I changed the vertical sensitivity from 20 millivolts to 10 millivolts. That's because with the 3-terminal regulator it doesn't vary but just a little. What you're seeing on the fuzz is this 3-terminal regulator is actually hooked up inside of a Bidex board, so it's furnishing power to the VFO. So you're seeing a little bit of that fuzz and the frequency from all that. So, but let's take a look and apply some heat. I'll turn the heat gun on and let it get a little bit warm. I have to be careful here because I don't want to melt any parts, but you almost have to melt something. I'm going to apply it to the board right now. You see, that didn't really change a whole lot. It maybe went 10 millivolts, and if anything, I applied more heat to it than what I did with the on the Zener diode. So what that says is if you want temperature stability, the Zener diode, at least this Zener diode that the two Zener diodes I've tested, really aren't the way to go. The little 3-terminal regulator is far better. We can cool it off with the canned air. See, it hardly moves. That's a lot better stability. Here's the test hookup for the 3-terminal regulator and the version 3 board. So it's actually in circuit and producing a regulated voltage. That's why we get a little bit more noise on the trace. Here's our test hookup for the Zener diode. Voltage coming in through, in this case we're using a 100 ohm resistor that was inside the version 3 board before we made the modification. Here's the Zener diode. So the scope's just hooked directly across the Zener diode. Let's try just a 78 LO8 by itself. I have 12 volts positive coming in here. I have ground in the center, and here's the output. So my scope is hooked, scope ground here, and the output here. Okay, here's just a voltage regulator out of circuit. You notice all the fuzz went away. We're still at 10 millivolts per division. We'll apply some heat. And that was a lot of heat. I probably raised the temperature over at 30 or 40 degrees. And we didn't even move 10 millivolts. We'll cool it back off. We'll apply some more heat again. Like I said, that was a lot of heat. It probably raised the temperature 120, 130 degrees, up to 120, 130 degrees. And it barely moved less than 10 millivolts. So you can see the vast difference between a Zener and a 3-terminal voltage regulator. How do you modify your version 3 board to put a 3-terminal regulator in? You take out the 100 ohm resistor that's right next to the power cord. You drill a hole right down through just a little bit to the right of middle on where the 100 ohm resistor sat, and that will take you right down into the ground plane on the other side. Scrape off the protective coating on the copper, and this is the 12 volt input here, this is ground, and this is the 8 volt output. The only other thing you have to do is remove the Zener diode. So remove the Zener diode, drill the small hole into the ground plane, solder in a 3-terminal regulator, and you have a regulated voltage for the VFO.